Hi, everyone. Thanks for joining. We're right on time. We have really a very interesting webinar here coming together. There's a few of you signing in right now. Always in the first minute, I stall a little bit to get people time to show up. But very briefly, um, we have a webinar that really is all around what can we do to get more out of LLMs with all the controversy around them? There's still a lot in the industry that is figuring out how do we trust this? And people talk about quality. I think trust is a better word um, for what's going on within our industry. And so, of course, we have people that have put quite a bit into their translation skills and capabilities and their speed and the like. And can we trust LLMs and what can we do so we can trust them better? Where is the human in the loop fit and all that? So we have some real research that happens. I do tell people this wasn't a graduate level research project, but it's very useful information, I think, for everybody. And it really influenced our own product development at Lingoport. So we'll talk about that. Now, without further ado, let's go to our first slide. Oh, and before I forget, there is a Q&A button within Zoom and a chat button. It would be really helpful if you have a question, write it down right away. We'll take questions probably at the end rather than in between. But if you write your question right away, first of all, it's fresh in your mind and you're not thinking about it later on as things go. And don't worry about it. Like if you write a question and we address it in the next slide or whatever, don't worry about it. That's fine. But if you put it all in the Q&A, it's a lot easier for me to track down your questions versus chat statements. Use the chat for like, hey, uh, can I invite my friend or something, which the answer is always yes. But but use the Q&A for the Q&A, and that would be great. By the way, we're also welcome to everybody on LinkedIn Live. We're there also. We have well over 200 people signed up in total. There's always a fraction of that actually attend the live event, but the recordings are pretty strong. I have no way of seeing how many people are on LinkedIn Live, so hopefully it's lots of you. All right, without further ado, we go to the introduction screen. Let's go back one screen, Milen. There we go. With us is Marina Pantcheva. She has been making the circuit pretty well, so hopefully you know her smiling face. Uh, she is really RWS's go-to person for AI technology, the practical application of it. She has a lot of education in that department. Go to her LinkedIn profile, you'll see more. And then Milen Epik, who, boy, I've known from before I started Lingoport, which is really, really a long time. So I won't say how many years that is. But anyway, Milen has been an expert in the field of everything from internationalization to true globalization consulting. And so she did a lot of the research that you're going to see here together with people at RWS. So she's the best person to take it from here. So Milen is going to drive the rest of the webinar. Olivier here is really just in case somebody asks a very technical question that's product oriented. He's here. He's probably going to go away. He doesn't until the Q&A, but I wanted him to show his face so he didn't appear out of nowhere. With that, I'm going to turn off my camera and let you take over, Milen. Thank you.
Okay, so the first question we have is what are the challenges that make software localization difficult? Marina, you want to start?
Yes, with pleasure, because this panel this webinars is going to be all about the research that you have done, Milen, on software localizations and the findings that you have. So maybe it's good to explain actually to the audience why software localization. And I actually believe that software strings are the hardest ones to localize, and there are 3 reasons for that. First of all, they're very short and they appear typically in isolation. And this leads to a lot of ambiguities not being possible to resolve. So because the segments are so short, because they appear each by itself, for the translators, it's not clear what context they appear in, and they cannot disambiguate. And the ambiguities can be different. For example, there can be semantic ambiguities. So you have a word such as charge, for example. So you don't know whether this is supposed to be charging a battery or charge a fee or in some financial meaning. You can have syntactic ambiguities. My favorite one is empty folder. So when you see empty folder, just like that, you don't know whether this is to be translated as a folder that has the property of being empty or as the action of actually emptying a folder, right? You can have part of speech ambiguity like view. What is view? Is it a verb or is it a noun? Or open, is it an adjective or is it a verb? You can have bracketing ambiguity, so you can have things like new file viewer. So is it like a new file viewer or is it a viewer of new files? Referential ambiguities, you have pronoun it, you don't know what is it referring to, and also visual ambiguities. Sometimes you really need to know where a string appears in the visual UI so that you know how to translate it. So ambiguity is one of the big curses of software strings. Then we have text length. Typically, software strings in English are very short, but in other languages, they expand. So in Spanish, you gotta add 25% more space. In some languages, up to 3 times more space. For example, Russian and Slavic languages, they really have long words with a lot of morphological agreement. And finally, one of the things that not only humans, but also AI struggles with is the profuse text formatting, placeholders, and tagged appearance in software strings. So we have lots of HTML tags, placeholders. They disrupt the flow of the text. They're disturbing also for translators. Sometimes you can have a string which is made primarily of placeholders and very little actual textual elements, and they have to be preserved. But sometimes they need to change position depending on how the translation goes. So all of that makes software strings very challenging to translate, and we can actually see them. This is not just a hypothesis. I used to work on a project where I could monitor the behavior of translator community, and I could see that when translators have a choice between choosing different types of content to translate, they would first go for marketing, then for UA help, online help, and the very last types of jobs to be taken by the translators were actually software translations. So it's a known fact.
Well, thank you, Marina. Now I want to show a slide where I've put some information here as to what the challenges are. And you've pretty much covered the first one, that it's short, it lacks context, as well as many other problems such as placeholders. And yeah, you've covered a lot of it. But let me jump also to the fact that when we do software localization, the other challenges come from the fact that software localization needs to actually work hand in hand with software UI design and also with the development teams. So what has happened in the past, but the desired model is that in the past, it was very linear. There is design, then there is software development, and after that, there is localization. That doesn't work. It's too slow. It needs to be a lot more dynamic. For one thing, software development is agile. They work in sprints. They need it fast. We need software localization to be in sync with that. But not only that, the design teams want to have more control on the design, and not only in the source language, say English, but also they want to be able to make their designs work for all the other languages. So they need to see it in other languages. They need instant translations coming back and forth and work iteratively on it. And the design teams want to be the UX authors, want to be in control of the software strings. So they would like basically localization to start early, which is also a goal for localization teams. They it's hard to be the last wheel with all of the pressures. If we can start earlier, we have a better chance of not only meeting deadlines, but doing a good job. So that's one of the challenges. And, the usual triangle of we want it fast, we want it low, we want quality as well. Typically, the discussion for decades has been you can't have it all, you can only have maximum 2, but not the third. But we really, with software localization, we need the intersection of all 3. So we know that with MT and LLMs, which are automated translations the 2 ways, we are getting them faster. We know that cost has been going down compared to human translation. So does this mean that the quality needs to suffer because we can only get 2? Maybe not. Well, going back to what Adam said, can we trust the quality? And this is what our experiments are going to be about. Okay, Marina.
So before we go there, before we actually describe the wonderful experiment that you have done, let's just step a little bit back and talk about, how do automated translations fare today, right? And what we have at the table today is basically neural machine translation, which is a very fast way to translate, relatively cheap, quite deterministic, and it ranges, the capabilities from generic MT to specifically trained MT engines on a particular type of content, potentially also with injected terminology, right? And then we have also translations done by large language models, which, unlike machine translations, are not deterministic. They are very probabilistic, which means that they can also be very inconsistent, but they're much more flexible because you can gradate there the quality that they produce by actually expanding the information that is sent to the AI before it needs to translate or convert a string from one segment to another, from one language to another. For example, you can enrich the prompt and the information you send to an LLM with RAG, with information about style, information about terminology, information about context. As you're going to see today, there can be much more information coming from other languages. Milen's going to talk about that, and also visual information. So AI offers us much larger possibilities to handle complex content such as UI strings. But this comes with a flip side. As the technology gets better, and it does get better with the advent of large language models that can be expanded, that can be made to reason before producing translation and so on, the cognitive load on the humans that are then asked to validate the output is getting larger as well. So while before a human post editor could have a look at an empty output and the errors would jump on the translator, and they're quite easy to detect. Nowadays, with advanced AI solutions for translation, the errors are much more subtle, and it takes much more cognitive effort to actually detect those errors. And that cognitive effort is on the human reviewer. So everything that is good has also, a bad side to it.
Thank you. So do you want to add to that as to how automated translations are today?
Well, I don't like what you mean by how they are today. They're just getting better and better. That is the conclusion from the technological development. They're being more widely used. More and more clients are actually opting for directly publishing the output from automated translations. And I think that for certain content types, low risk content and content that where quality is not so critical, or the speed to market must be incredibly fast, automated translation are a good solution, provided the languages they are applied to are actually supported by technology. Because, if you have a good solution that works on Spanish, that doesn't mean that you can apply to isiZulu and get the same quality results.
Great. And one thing you said is that they're getting better. And with that, we wanted to know, how much better are they getting? So our experiments that Adam referred to is going to take a look at machine translations versus LLMs today. So before I can talk about the experiments, just a little bit of what these experiments are about. We tested them with 2 different data sets, software strings and highly ambiguous strings. We needed to create LLM translations. These are the tools that were used, basically OpenAI, GPT-4 and 5, and the many versions of them. For MT, Google Translation was used. And of course, one needs a second AI, which is the quality evaluation tool. We started by looking at Trado Smart Review, and then thanks to RWS collaboration together, and a shout out here to Paul Filkin, a open source TQE was created, which allowed me to run a lot of experiments in many different ways of preparing the translation output in different languages so that I could statistically get some results. And then we also took a look at how this works within Trado Studio. So basically, this open source evaluator creates some reports that I put some excerpts of it here. And it gives us an average score of quality. It gives us a median score, provides some different examples of the segments that have issues, what the issues are, with guidelines as to what is the problem. These can then be fed and linked into an online editor or like a Trado Studio. We looked at it in Trado Studio so that it can guide a linguist to quickly go into those segments. This is basically what Smart Review does, but so does this tool. And then what you can also see here is that it produces some score distribution and looks at the different types of issues that came up with how those issues were broken down in terms of percentages. So with this methodology and what I described before, the ability then to make a human reviewer quickly go to a highlighted segment, this is the one that has a problem, and providing some feedback to the linguist, further productivity gains can be gained, and that's something we wanted. So the solution provides that too. Okay, so that was the methodology. And this is what we found out when comparing machine translation to LLM. And I need to say this is the plain vanilla version of them, meaning this is an untrained machine translation, and it's an LLM with just a very simple prompt. The prompt says translate from this language to this other language. We saw that, as you can see here in all of these languages, LLMs actually got a better score. Not only did they get a better average score, but also the number of segments needing review was dramatically going down, which means there will be less work for the humans and therefore more efficiencies. The other thing we gain from these experiments is to take a look at how the issues were broken down. And what you can see here in this table with all of the greens, the LLMs were consistently better with an accuracy and context coherence score. While interestingly enough, MT had better style and terminology scores. Okay. Anything you want to add, Marina? If not, I will go on to the next question.
I just thought it was a very curious finding that MT outperformed LLM basically in the areas of terminology and style, and LLM outperformed MT in the areas of context, coherence, and accuracy. What I would have expected, just purely theoretically, is that LLMs would have outperformed MT in the area of fluency and context coherence because of the flexibility they have and because they generally produce much more fluent language. And for MT to outperform LLMs on terminology and style, I would have assumed that this wasn't a generic MT engine, but one that was trained specifically on that type of content, because when you have a custom trained MT engine, then it absorbs the terminology and the style of the training data, right? So very interesting. Maybe there is some spillover effect or something. Maybe the generic MT actually has been trained on that type of software segment. It is possible, and that's why it was better on terminology. But the good thing is that the fix is easy, because it's really easy to make LLM outcompetes or empty OMS terminology and style, since they can be very simply injected into the prompt. So whatever drawback there is here, it's very easy to eliminate, basically.
Yes, that was actually very curious of a finding as well.
But easy to fix.
Yes, and also this evaluator is also very tweakable. So one can keep working and look at it. And
yeah, which actually brings us to augmented prompts, because all these tweaks and all this additional information that can be provided to an LLM so that it can handle terminology and style and context better, this boils down to augmenting the prompt with additional information, which is exactly what you did.
Right. And so this now then brings us to augmented prompts, what we call at LinguaPort string level prompting, because the prompts get associated with a string. So the first experiments are about using multilingual cues. Basically, instead of sending an LLM, just the source word, let's say the word property, that you need to translate from English to another language, you send along with that two or more languages that have previously been translated. So the same project, maybe these strings had been translated for 5 languages, and now you're adding some more languages. You can feed that at a string level as input. And now we want to see what the results of that would be. So by the way, doing this is what's called multilingual triangulation. It's research that has been done for decades. You can find lots of white papers and people's PhDs on those online. So our second experiment said, okay, now let's compare the LLM with very simple prompts versus providing these string level prompts with multilingual context. And our findings were curious because they were mixed. If you look at Turkish, Hungarian, and Finnish, they've all improved. But Romanian actually did worse with those prompts. And Norwegian did even worse. And also looking at which segments needed review, it decreased in those same 3 languages I mentioned before, but it really got worse with Romanian, especially Norwegian. So that made us wonder, well, is it perhaps the languages that we chose? Maybe, for example, Japanese is in the same language group as Turkish, Hungarian, and Finnish. Oh, maybe there are more cues in that language to help the languages in the same group. Or is it perhaps that the AI that does the QE evaluator actually didn't know about the context? So with this, with our collaboration, the QTE tool was updated to also know about the context, and the results were significant. They were now significantly better when those cues were produced. And that was across all of the languages. And also the number of prompts that needed to be reviewed went down. The number of segments that needed review went down. Then we said, well, okay, let's go back and reevaluate also machine translation, because that was done with the old tool. So now we reevaluated, and we see that going from machine translation to LLM, it was better. You add LLM, some cues about the language, and it knows that. And systematically across the board, we get the best results.
Can I just add
Yeah.
something to that? Because I think this is a beautiful illustration of something that happens also when we use human translator and human reviewer. So what happened, the reason why we got these surprising results for Norwegian and for Romanian is because the reviewer AI tool didn't have the same information. It had less information than the translator AI tool, which used multilingual triangulation and cues from other languages. So it didn't know how to evaluate. It was victim to the same ambiguity that AI tool without multilingual cues will be exposed to, right?
Yeah,
so
similar
thing, similar thing happens when we have a human translators who is very, very experienced, being then evaluated by a human reviewer who has much less experience and knowledge. Okay, then the results are not so meaningful because the reviewer has less information than the translator. That's what happened here. So what you did, you basically calibrated. You basically brought up the reviewer AI and the translator AI to the same level of knowledge. So the results were more meaningful. And I think that's a beautiful illustration of that. Another thing I very quickly wanted to add is, and it's a little bit nerdy, and this is the fact that language cues are really helpful as long as the source language and the cues actually have, as long as the language for the cue has a higher semantic resolution than the source language. Let me give you an example. For example, if you have, let's take the word cheese. Okay, the word cheese in English applies both to cheese that is yellow and that is white, right? This is all cheese. Whereas in one of my native languages, we have different words for white cheese and for yellow cheese. So when a translator says cheese in English, the Bulgarian translator wouldn't know, is it yellow or is it white? If we give there a cue from Norwegian, which has just one cheese word, that's not going to help the Bulgarian translator at all. But if we give there a cue from, say, Slovak, I think, or Russian perhaps, that distinguishes between the two types of cheeses, right? Then it's going to help. So what is important here is to actually get languages that can disambiguate, right? So that the cue language doesn't carry the same ambiguity as the source language. And that's tricky because it's not that easy to choose.
Right.
So
And sorry, go ahead.
So let's continue.
Okay. We did a second experiment also with 20 highly ambiguous sentences. These were not actually software strings, but it was an experiment. And I'm just going to kind of jump over this in the interest of time. But shortly, you can see that when there is no string level cues, the score is 81. But when you have the string level cues, then it goes to 96. And this one was done with Chinese translations. This is another one with Turkish translation. Again, a huge jump from 70 to 94 score. And the main areas that improve are on accuracy and context coherence. Okay, so our next question is, okay, so the evaluation has been done by machines. So AI translation is evaluated by AI. What about, did humans evaluate these translations? What did human linguists think? So for that, what we've done is we took the LLM translations with the string level prompts and took the results of that. And we had RWS do basically an MT style productivity analysis. If you have machine translation, a productivity analysis is done to see how much productivity you can really get. If the scores are not good, maybe it's not worth doing MT. But if it's good, definitely it's going to be worth it. So there was a solid pass on all of the languages, except Greek. There were some issues with the testers, so don't look at that. But the other 4 languages, they were all a solid pass, which meant that there was very significant productivity gain. These translate to these productivity gains. And basically what it means is, if in a given amount of time, you can translate, let's say 100 words, now when you're reviewing, when the human is reviewing LLM translations with string level prompts, in that same amount of time, they would do 220. So that gave us some more confidence that this was actually helpful. And furthermore, then when we compare the LLM with string level prompts versus a machine translation results, the advantages of the LLM is that, first of all, as we've seen, accuracy is better, with overall translation scores also being better, which then result in good productivity gains. Oftentimes, as I've mentioned, MT is not suitable for software strings, but we did get good results here with LLMs, so productivity is good. The other advantage is that when using MT, there's also some upfront costs. You need to train every engine for that language. So there are training costs, but also those get multiplied by how many target locales you have. Whereas with LLMs, you don't have any of those training costs. Also, LLM translations are cheaper than MT translations when you look at a per word cost. I don't have any data on this, but it's all over the web. I'm expecting everybody knows that piece. Okay, now we want to go to the next question. And this question here is, what if there are no existing translations? Are there other options to string level prompting? So as I've mentioned before, the cues were taken from other locales that were translated. What if you're just starting and you have not translated anything? So is there anything that can be done with string level prompting? And the answer is yes. And that's providing visual context to make the translation better. Just like a human, benefits by seeing the string within its context, and in software, the context is where is it on the screen? What else do I see around it to make judgment on what this means? Providing the same input to an LLM can help us as well. So in the screen here above, you see a localizer string manager. There's this word billing, and the visual input comes up here. The context, the billing is in fact also marked within the screen. This one, the lower one, shows that localizer has passed this information to Trado's online editor, and you can also, the linguist can take a look at it. Here's droid. This is how the droid looks like. So this is what we mean by visual context. And with that, we will show you a demo of how this works.
Hi, this is an illustrative example of how to use prompting for LLM-based translations, either via a TMS that would have a GenAI type of translation engine as part of their workflow, or directly with an LLM like what we're going to show here with ChatGPT. The example we're given here is using a LinguaPort public Acme prompt repository, and it's using ChatGPT 4. There are only 4 source words, and those source words are the following: coat twice and washer twice. We are using those examples because coat and washer, like many other words, may have multiple meanings, and so the translation may need to have prompting in order for it to be accurate. Let's go back to localizer. The first prompt level is on ChatGPT for the connection that we have. Let's go there. Here is the ChatGPT 4 connection. By default, we have a system prompt, meaning every project that uses this connection will at least have this part of the prompt. So let's just make something extremely simple. Translate from a source locale to a target locale. Those 2 variables must be part of the system prompt when you're going to a ChatGPT or a PXML going to a TMS. Let's save. We're back on our project. Let's look again at strings. So again, it was coat and washer. Let's translate without any prompting. Here we go. You can see the process is happening here, and the strings are back. It's now 100% translated, as you can see with the green indicator here. And the target locale, by the way, I only picked up 1 French just for this demonstration. So let's go to the project here, going by overview and going to this Acme on the prompt branch. So let's go to the prompt branch. What was just translated now, using the basic thing, is the following. You can see that code was translated in the context of a hardware store. The code could be couche. In the context of a hardware store, code could be this. So what you're seeing here in the first pass is that it's hesitating between different translations, but it's not a translation. It's more of a thinking about the translation. So let's go back to Command Center and let's change again the prompt for the ChatGPT prompt. And let's edit the ChatGPT system prompt. Here we go. I'm going to go back to the default setting that it should be. Here we are. Let's save this. You'll notice that here, in terms of special consideration for UI is brevity, clarity, consistency, action-oriented, return only the translated text, no explanation. That's kind of crucial, actually. Let's go back to the project and let's resend the string to be translated with the new prompt here. Here we go. This will send all the files that are part of this onboarded project to the locale that I clicked on, so to French here. And let's check what the French now looks like. So locales, it was just retranslated now on packet number 2. Let's have a look at the French file. First of all, you see that now there is a translation. So with a word as short as coat or washer, we don't have very much in terms of context. You notice that here we really would like to have a coat of paint, which is couche, but this one is something to put on for your back, which is manteau in French, not couche. So on this one, washer, we would like it to be a washing machine, and here it's a washer that goes with a nut and a bolt. So again, this is not quite what we want, so we need more prompt. Let's go back to Command Center. And now there are two things that we can do. In terms of the prompt for this project, maybe we're going against a hardware store, or maybe it's a retail store or something more specific. The prompt here was a hardware store. Now let's add an additional layer here, which is for each one of the strings, we are going to add a contextual image. This can be done in 4 different ways. Here it's just going to click on the add an image, this button, and to assign it to the string. So let's add some images here. Let's add another image for this one. So let's quickly check for each one of them that we have the images that we want. Coat of paint, a coat to put on, a washing machine, and a washer for another mode. Now let's send this to translation again. So in localizer, we're going to do the same thing here. We're going to resend everything to be translated into French. The translation is back. And now let's have a look at the message.properties again in French. It was just translated now for packet number 3. Let's open it up. The coat of paint is couche, which is correct. What you put on is un manteau, which is correct. A washing machine is a lave-linge, and a net washer is une rondelle. This shows how prompting can work together well with an LLM to have a more accurate translation and have an overall prompt to indicate how to do things for brevity, clarity, and have no explanation and so on to get only a translation. And then it can narrow the translation to the one that you want, especially with context, like in Command Center with the images that we have associated with the strings. That's it for this demo. Thank you very much.
All right. So the context has been used to improve translations in other content types for a very long time, but providing context for software has been more difficult. And we at LinguaPort have been working on that for quite some time. And now we are able to provide context and make it easy to capture the context and to deliver the context with 4 different methods. What you've seen in the demo is that context was captured via screenshots and is associated. That's one way. There's also the method of capturing it through a Chrome browser for web apps, through an API, or through Figma. Figma is actually the most efficient way to gather context. Additionally, if we can start with Figma, then we know that we can begin translation or localization early from the design stage on. This also has the added benefit that we can connect the design, the development, and also the localization, those three gears I showed at the beginning, together. And this is what we call Figma to Dev. So the way it works is this. The designers are working on their design in Figma, and when they're ready, they initiate translations from the localizer Figma plugin. And through that, localizer is able to get the strings and the associated visual image, the context. Those two can be put together. The actual string is marked, and it is passed to translation. The translation can be via an LLM, which will come back real quick. It can also be through traditional translation methods where there is a TMS. Well, the TMS itself in the workflow may have an LLM or not. If it doesn't have any LLM, the humans will see the provided context. That's going to help. Or if there's an LLM, that can be passed to the LLM for better results. Humans can still review it if they want to. When the translations come back, these are returned by localizer back into Figma. So that makes LLM translations immediately return back to the designers, so they see the translated strings as well, and they can adjust their design, maybe make the buttons bigger, shorter, change how the layout is. So this really helps the design teams. Additionally, it's pushed from localizer to the developers. It's basically placed into the repos in the form of resource files, which means that each string is also going to have its string ID created automatically, both for source and for target translations. So a lot of the burden for development is taken away. It's automated, which developers like. Designers like this because they have control over it. They get immediate translations. And if later down the road, maybe development needs to add some strings or change a few things, localizer always was able to pick up those changes from the repo, can send them back to translation and get an update. And the latest version of the string is going to be put in the repo, and the designers will get that too. And lastly, if there are human reviewers, if there's still human in the loop, then those come in later because humans are slower than machine. But localizer keeps track of what is the latest and will push the latest, update that in the repo, and as well as the designers. So this is the Figma to Dev solution that we are just providing with our latest releases. Okay, so now we've looked at two different ways of providing visual context. One was with that multilingual triangulation, and the other is providing, sorry, I think I misspoke. Two different ways of providing string level prompts. One is with cues from other languages, and the other is with visual context. So the advantages of visual context, as mentioned before, is that you don't need any other locales previously translated. It can begin from the very beginning with first locale. Additionally, we can hit the goal of beginning localization early from the Figma design stage. Yes, you do need to collect visual context, but we make that easy in 4 different options. If there is a drawback, that's that with cues from other languages, you could also get cues maybe on style or do not translate words. Like if you saw that some words were left in English in some other languages, then you can take that when take that as a cue when creating new translations. But this is also solvable because you can add also more information at the project level prompts. I think some people call them user level prompts. So terminology, do not translate list, or anything on style can be provided there. So on the other hand, with multilingual triangulation, yes, that is a pro. We did talk about these first two cons, but looking at one other drawback is the translation quality is actually dependent on the other languages you are triangulating on. So if they were not very good translations, then the new ones you generate are likely going to suffer from that same quality too. Also, you probably need to think a little bit more of what languages to prompt with what. So it's not that easy of a decision.
Can I just make a comment here? Like the last point
Yeah.
that you made goes back to what I mentioned, that the languages that you use for your cue need to have the same semantic resolution, make the same distinctions as the target language. But there's one more difference here. I was just thinking about it. Difference between visual context, providing visual context, and using multilingual triangulation. Visual context cues are going to also help humans, right? So it's both the human validators, the human reviewers who are going to have access to that information. Whereas multilingual triangulation, that is something that is meant to help the machine only, assuming that a human German translator will not necessarily speak Japanese and Romanian as well, to leverage from those additional examples given as part of the context. So visual context serves double purpose, helps the LLM, helps the human.
Very good point. And those string associations with the visual image also remain in localizer. So I had shown a previous image where you can look at it in localizer string manager. So yeah, it has a lot of other uses. Thanks for bringing that up. And on the cost, just a very quick study looking at LLMs with string level images as prompting. When you pass an image costs you more tokens. So we wanted to see where that brings us. So the experiment we did looked at, I think this was like 18,000 words, and there were like 2,300 total strings, but on average, every string was 7 words. Each string had one image. They weren't sharing an image. Each one of them had an image. And we realized that each of these images on average took about 1,700 tokens. So we have some references I'm going to show you, but you can find the token cost of each of these. And we did the calculation. And we saw that even with images put in, we're looking at a fraction of a cent per word as a cost for an LLM that also has this string level prompts with the images. How do we compare this to machine translation? The first inputs I found on this through my research was that the cheapest was like 1/10 of a cent per word with MT. But then I found another recent reference, and it's talking about Microsoft Translator would be 0.5 cent for 1,000 words, not characters, 1,000 words, which then is equivalent to that. Our LLM is still within the range, if not a little bit better. And the LLMs we tested are in this range. So there are some that are cheaper and some that are more expensive. So this is a middle range. LLMs keep improving, they become better and cheaper every day. So we think that getting better accuracy and not being more expensive makes LLMs with string level images quite attractive. Yeah.
Can I just make a small comment on that?
Of course.
When it comes to cost, like LLMs do not appear to be much more costly, but I got curious, how do they behave when it comes to speed and latency? Because from my experience, I know that when I prompt an LLM just with text, the answer is almost instant. But when I need to prompt an LLM to also process an image, then the waiting time is longer. The response comes slower because an LLM needs to convert the image into tokens, process the tokens by organizing them in patches and so on. Humans, on the contrary, are extraordinarily fast at processing visuals. Basically, it takes only about 30 milliseconds to process an image. That's why an image is worth 1,000 words, right? Humans process words sequentially much more slower. So my bet would be, or rather I would wonder whether a human is faster at processing an image as a contextual information than an LLM, and whether LLM lose time, so they might be cheaper, more efficient, but at the same time, the speed of the response might be slower. I know that this wasn't part of the research, it's just food for thought for future explorations. That would be very interesting to find out.
Yes, I agree, and that was not measured. However, you can send an image to the LLM as is, or you can translate an image into words and then provide that to the LLM. So I believe that the image is faster, but I have not measured it. Maybe in terms of speed, if if Olivier has some feedback, we can provide that, or we can, it's not part of this test, but
it might exist actually as a metadata. And like in recording the responses, you may have that as a metadata. How long time it took for the LLM to respond?
What's really hard to nail down is whenever you have humans in a task, there's handoff time and background processing time. There's distraction. There's all kinds of things in the real world that change things. I think we're kind of in the minutia of less than a second. But it's interesting all the same. I mean, one of the things that automation to begin with, like at the very highest level, gets rid of is that idea of, oh, we have this Excel spreadsheet, and that's Excel is still probably the most popular localization environment that there is. But there is handoff time. There's, oh, I emailed somebody this task. It's buried in their list. They didn't see it for 3 days, or maybe they just didn't see it. I mean, there's all kinds of things when you talk about humans that are even higher level than what we're talking about is context. We're kind of assuming that all of that is efficient. Okay, we've got some questions. I want to spend time on them. Some of them were definitely answered during the webinar, but I'll still just go over them anyway. A really early question is, when we speak about LLM translations in the context of current translation tools, do these work at a segment level, or are they able to analyze, understand the context? My impression is that many tools are doing the first, whereas we should maybe be doing more towards the second. Relevant to strings when we talk about segment level.
Yes, and that's exactly the point. It's not really looking at all other segments and other context around it. And I see that Paul has actually answered this. Yes, that's the point. It's putting context with a string level. That's okay. What's new. Yes.
I'm going to keep moving on so we have time for everybody. There was a question that I made a comment on, and it threw it into the answered section. Sorry about that. Here, is there any published paper or document that informs the community of a ranking of LLMs depending upon the language pair domain? Is there something that is being constantly updated? Also, have you done some experiments with simple prompts that have localize instead of translate? Two really separate but good questions there. Marina, can I pick on you?
The first one, I will let Marina answer.
Yeah. Unfortunately, that is the holy grail of our industry at the moment. There is no paper, or rather there is no place where you can get a continuously updated measurement like metric about how LLMs and the new models that come out rank for translation tasks per different languages, domains, content types, and so on. There are studies, but they are delimited in time. So there is a study that focuses on a particular set of language, particular set of models, does the measurement using whatever metrics, like 5 metrics they choose, and it's a discrete, it's not an ongoing continuous study. One of the reasons is that it's really, there has to be a team dedicated to that, doing this every single day as a full-time job. And usually such research is a project-based research, so it has a start and an end. The closest study that I know about how LLMs fare, different LLMs from different languages, is actually a research that is coming from RWS, an LLM study done by Train AI team that compares different LLMs on different languages and how they fare on content generation, for example, nothing specific for translation. And then there are some papers, which compare LLMs on usually not more than 4 different languages, right? So unfortunately, there is no such thing, and it would have been lovely if there was a place where we could get that information. But nothing constantly updated.
I'm sure each provider claims theirs is the best.
And that might very well be, because it really depends how you set up the prompt. Usually very subtle changes in the prompt can actually change the response by the LLM very significantly. That's why I love the second question, which is there a difference if you say localize instead of translate? Actually, yes. Actually, yes, because when you say localize, you give the LLM information that it's not only about converting from one language to another, but you also need to take into consideration cultural differences, style, the way you address users, and so on. So it does make a difference. It's better to use localize when you really mean localize instead of translate. The LLM is going to be sensitive to that different usage of a verb.
Okay, great. We have a couple here. More and more. Okay, good. Keep the questions coming. We'll try to address all of them. We're going to run over the hour, but unless Marina, you have a place to go, I'd like to get everything answered here. At scale, say 10,000 segments, what is the false positive poor translation rate?
I think the answer is it depends. It will depend on what you're using to prompt it with. If you prompt it with other language cues, as I mentioned, there are different items like the quality of what you prompt with or what your choices are for prompting that's going to affect it. It also depends on what languages you go to as a target. So this is not something we've measured, but that's my belief. I'll see if Marina wants to add to it.
I do. A general answer, generic answer, not that specific question, because really the answer depends, like what is the content, what is the LLM, what is the prompt, do you inject terminology, and so on. But generally, just to talk about the expectations people have from LLMs, large language models, it has to be kept in mind, are probabilistic machines. They are stochastic, and they are in a way random, right? So you can send the very same prompt 100 times, you will get 99 times the same answer, and then the 100th time it's going to be a different answer. This is not something that happens with machine translation. They are deterministic. So with LLMs, keep in mind, I believe it's almost theoretically impossible to get 100% accuracy, 100% correct responses 100% of the time. Edge cases, like really very exotic types of segments, things that the LLM never saw in its training data, they are very likely to come back wrong. So don't expect 100% accuracy, just like we don't expect from humans that they're also going to be 100% of times correct. But it would be unrealistic to say that we are targeting 100% accuracy with LLMs. In our daily work, we work with LLMs a lot. We see accuracy up to 99.8%, but never 100%.
Okay, good. I will just add that within Localizer, we have the concept of automated string level prompts with visual context. There's the project level prompt and then the system level prompt. So that's 3 layers. And all of that works together to add to accuracy. I would agree that it depends, but in every run of this, we saw greater productivity. And the idea, again, there is a real premium on speed for software. The complaint I hear over and over again, and I'm going to use a literal quote, the complaint from developers is that localization is a boat anchor on their work. It runs behind. And even if you're 2 days behind, which is really, really efficient, you're still behind. And so with this system, you're actually shifting left even before development starts to have some localization ready, and the developers just plug in the resources. Of course, if the developers change something in production, that gets handled also automatically. So that's nice. And that does happen. Okay. Can I use my own model with localizer? For example, if I have a LoRa, I don't know what that is,
I think
adapted
it's
model.
Laura.
LoRa, okay. Adapted model running on premise. So your very own AI on premise, and that's a great question. Milen, do you want to take that, or you want me to?
I
Or
think that's for
Olivia?
me actually.
It's
If
more
it's on
Olivia.
product, like if it's on product, it should be me.
Okay.
So we have different ways to connect to translation systems. One of them can adapt yourself to your own translation system, being a ChatGPT, your LoRa model, or something else. So we have a way to go to one part of your system and then you adapt it to yours. And then LoRa, if it's LoRa, we're actually working with translated, and there may be something already there, depending on how you've done your integration or what is before with translated.net or translated.com. So we adapt. And if you want, Steven, we can chat separately on that.
Okay. That question was asked by somebody I know for a lot of years, so I can reach out. Okay, just sharing the most recent paper on the topic of LLM rankings that I know. It's really interesting read in case the attendees are not already aware of it. The link is right there in your Q&A. I think that's super cool that you're able to provide that. That includes, for example, Gemini 2.5 Pro, but now we have their newer model and so on. So I suggest everybody has a look at that question comment, and that's super cool. All right, it's in the answered section now. I don't know how it ended up there, but I didn't click it. Okay. All right, I think we're complete. Going once, twice, three times. Any other question? I think we're good. Thank you, everyone. You will automatically receive a link to the recording. I think I'll work with Milen to put together a PDF that we can distribute. There were some questions about being able to read some of those slides, and yes, I can really appreciate that we were pretty detailed.
Essentially, the demo was recorded.
Yes.
Yeah.
And the demo is available on YouTube. So Milen or Adam will send the link to the YouTube demo. Actually, it'll be easier.
Actually, it'll be Kate, but who
Yes.
is standing behind.
It was on the demo, and I didn't see that in time, and I'm not really sure if I could have made it bigger on the screen, but yes.
All good.
You will receive
All right.
that.
Thank you, everyone. Most of you stayed with us the whole time. Very good. I appreciate it, even though we went a little over. And thank you very much, Marina. Always a pleasure to work together with you and your team and all the folks at RWS, and Milen for really being the juggernaut on this. This is a lot of work, and it's not like Milen doesn't have other things to do. So I really appreciate it. You're getting a nice comment on the Q&A interface there, Milen and Marina, for the information. All right. Thank you, everyone. Take care, and we'll be in touch. All right. Happy
Thank
New
you.
Year,
Thank
too.
you.
Happy holidays and New Year. Bye-bye.